takes the pressure off the existing supplies, and that's been one of the key drivers for us to do stormwater harvesting here in Melbourne, is that the more stormwater harvesting we can do and the more water we can take from the stormwater system, the less we have to get from our dams. Because our dams are set up so that they will hold water over multiple years. So if we get a few years of drought, we can sustain and survive that, because in Australia, we can go 3, 5, 6 years of drought easily. So we know we've got to be ready for that. So it's designed that they'll fill up in winter and they'll empty in summer, but we can go a few years with dams. But every year, the level in those dams gets lower and lower and lower, so we can only survive so many years of drought. Now, with rainwater tanks and stormwater harvesting, that's taking water from the urban area. Now, the urban area is not part of the catchment for our dams. The water goes straight out to the bay. And we estimate that in Melbourne, about 500 megalitres per year of stormwater comes off all our buildings and paved areas and goes straight out to the bay. That's equivalent to the amount of water that we import from other catchments and we bring into Melbourne and we use for our drinking water supply. So if somehow we could magically capture all that stormwater, it would be enough to supply our entire potable demand. Now, that would never happen, it's not possible, it would never be economically feasible to do that. But even if we got 10% of it, that would take a huge pressure off our dams. That would mean 50 gigalitres of water a year that we're not taking out of our dams. So after 3 years of drought, that would be 150 gigalitres of water that could be sitting in a dam instead of being used for potable supply. So that's where we're coming at with stormwater harvesting in Melbourne. So the second thing is that it helps to, as I said, get rid of the pollutants. So we take out some of the loads and we stop that water from going downstream. We help to protect the downstream ecosystems. Thirdly, allows us to maintain some of the hydrology. We know that we've reduced the amount of infiltration and groundwater recharge that's occurring. So what we can do is use stormwater harvesting and irrigate not just the sports field, because we're going to irrigate that anyway, but if we've got extra, we can irrigate some of the parks and other areas around it, help keep them green in summer, contribute to cooling and stuff like that, but also contribute to recharging groundwater and base flows during the time. So, urban heat. This is an illustration of some heat mapping that's been done. So basically the red areas are hot, the green areas are cool. And what we can see is that anything that's well irrigated is cool. So you can see the ovals nice and green where we're irrigating. And we know that the temperature of irrigated areas is quite a bit lower than any others. So 36 degrees for irrigated areas, 37 under the shade of the trees. Concrete's at 48 degrees on this heat wave day. Keep in mind it's a very hot day. And the roads are at 56, so there's a huge difference. Where would you rather be standing? On the oval, obviously. Well, probably under the trees, actually. I think I'd rather be in the shade. But another benefit is that it can help to reduce the amount of runoff that's occurring, and just as I showed you that graph with the rainwater harvesting, the stormwater harvesting can help to reduce flooding impacts so that we can get some flood mitigation. And recently we've also been getting serious about talking about having systems where we've got combined flood mitigation, stormwater harvesting, reuse storages, so that we can use it when we've got a flood and capture water, but during the rest of the year we can use that storage and we can capture water into it, we can harvest water out of it, and if the Bureau says we're going to get 50 millimetres of rainfall in 3 days' time, we just pump all the water out of that storage so it's available and ready to use. But otherwise we can just use it to store water most of the time. And it can give us some cost savings. It does depend on the system and the project. Stormwater harvesting systems are not cheap, so sometimes they cost as much as the potable water supply. If we find a good location, there's already some storage, there's already some of the elements in place that we need, it can actually be cheaper to do stormwater harvesting than it is for us to get water from the desalination plant kilometres away and bring it to certain locations to supply that water. So this is a rough idea of costs. So water efficiency is obviously the best thing to do. Surface water, which is our dams, is dirt cheap. Precinct scale stormwater harvesting is not too bad. It comes in about $3 a kilolitre. According to this graph, it's on about par with the desal plant. I can tell you now, I don't know what stormwater looks like now, but that desal plant cost is at less than half what it's actually costing us to get water from our desalination plant. If we do the costing in the same way that we cost the stormwater harvesting schemes. So the government likes to play funny numbers with what things cost, but it's really costing us about $6 a kilolitre if we look at what the water authority is paying for that water. So what does a stormwater harvesting scheme look like? We have a catchment where the water's coming from. We harvest or we divert that water, so we might actually divert the water out of the pipe or out of the channel in an urban area. We treat that water and then we store it, ideally, in an ideal world, and then we redistribute that water back to a sports field, like an oval or something like that. We use it for a golf course. I had a call from someone yesterday saying we've got a golf course, they want to do stormwater harvesting. Can we talk about it? Use it for parks, use it for industry. So in Adelaide, they've got a stormwater harvesting scheme where they take water from large numbers of drains, they put it all into wetlands, they let it go they re-inject it into the ground, and then they take it out, and they use it to supply it's like a wool scrubbing industry, so basically it cleans the wool before they can use it. That system harvests about a gigalitre of stormwater a year on average, so pretty significant. Most of our systems in Melbourne are much smaller. They're in the order of 10 or 20 megalitres a year, so much smaller for a park scale system. So when we start looking at stormwater harvesting, we have to think about some other stuff though. If we're talking about the environment, okay, we want to get rid of the heavy metals, we want to get rid of the nutrients, we want to get rid of the sediment, etc., etc. But if we want to harvest that stormwater, suddenly we need to think about other things, because we're taking that stormwater, we're spraying it over a park, people are walking around in that park, and we've got to think, oh, hang on, is this water safe for people to be walking around in, or has it got pathogens in it? So we have to treat the water differently, we have to think about different pollutants. So obviously the pathogens are the main one we're worried about with the stormwater harvesting scheme. Nutrients, we still don't want nutrients in our storage because it might get algae in it and that sort of thing, but if we've got a bit of nutrients in the stormwater and we put it on the sports field, hey, we don't have to put as much fertiliser on it, so maybe it's not such a problem. So it depends on what we're doing. Usually we'll remove the litter, take out any fine pollutants, take out any heavy metals, that sort of thing. So we might have a litter trap, a sediment pond, and then a biofilter, for example, or a wetland. But then we'll usually add another step, and that's where we will use what we call UV or ultraviolet disinfection. So basically we'll pass the water through a pipe and we'll use UV lights, UV lamps to disinfect the water and kill any bugs that are in it, and that makes sure it's safe for irrigation afterwards. Alternately, we might irrigate the water underground. So if we're just taking the water and then we're releasing it to an underground storage underneath the sports field, or if we're putting into subsurface irrigation, we don't have to worry as much about pathogens because no one's touching the water anyway, they're not coming into contact. So we can be a little bit less stressed about that. It's worth saying that there's a wide range of risk tolerance for this. We have councils that are doing all of the treatment I just showed you in UV and then they're irrigating their sports fields. We have some councils that are literally taking the stormwater, diverting it to a pond, and then they're just irrigating straight out of that. Especially if they're doing a golf course or something, they just go, we don't care, we'll just irrigate and not worry about the risk. So there's a range of levels of risk tolerance, there's a range of levels of treatment we can provide. We tend to err on the higher caution side, and we say it's better if we can remove any litter and sediment because that's going to block up the system down the track. It's better if we can keep the nutrient levels low because then we're not getting problems in our storage, and we definitely want to be taking pathogens out because the last thing we want to do is be running one of these systems and then someone gets sick and then the government says, okay, that's it, we're not having any of these systems, we're going to ban those. And we've seen that happen with recycled water in other countries where someone's got sick and then they've wound back the tolerance and the allowance for those systems. So it's important that we're managing these risks carefully. So Royal Park, I think I showed pictures of that before. We've got the wetland, water is being taken from Mooney Ponds Creek, which is basically a concrete channel at this point, diverted into the wetland. I think there's another drain directing water into it as well. Gets treated, gets directed into a pond storage. There's some storage tanks under the sports fields, and then they're using that to irrigate this area. So it's a pretty common setup. I'll talk about another one that we've designed. So this is Elmer Park, and it's in Brighton. So it's, I'm trying to think if you're going anywhere near there. It's near St Kilda Pier. If you get down there, just south of the city. So we have a diversion. We've got a stormwater drain that runs directly through the park. Very convenient. We divert the water out. We put it through a gross pollutant trap, which captures all the litter, and then we drop it into a sump. And then from there, we pump the water up out of the sump, and we put it into a bioretention or a biofilter on the surface. We treat the water, and then it goes by gravity. It drains back into 2 underground tanks under the oval. And then from there, we pump the water out, we disinfect it, and we use it to irrigate the sports field, and then we also use it to irrigate the rest of the park. And in this case, the park's a bit complicated. There's 2 halves of the park. There's a railway line running down the middle, and the railway line is sunk into the ground. So we had to spend a huge amount of effort figuring out how we were going to get an irrigation line running over the bridge, over the railway line, and over to the other side of the park. So that took about a quarter of the project thinking and effort, I think. Never deal with the railways, they're always difficult. So this is what it looks like under construction. So we dig a humongous hole underneath the sports field. In this case, we couldn't do above ground tanks because the park's worth too much money to put things above ground, so they wanted it below ground. So we dug a really big hole. We put in a giant concrete tank, looks something like that. And we put in a second one. So that's our storage, 1 megalitre of storage underground. So big by stormwater harvesting standards, not big by some of the flood storages you guys will do. So that's the 2 storages more or less completed. So you can see they're circular tanks. Each of those hold 500 kilolitres of water. And then we built the sports field back over the top of it and reinstate it. Now they had to get all this done over a period of 4 months because they've got the sports, so you've got the cricket in summer and then the football in winter want to be playing on the sports field. So we want it shut down for as little time as possible so that the kids can get out and keep playing their sports. So they had to do all this in I think it was 4 months, it had to be finished. Then we've got the bioretention system. So you can see this is just forming up the concrete. Then we're putting in a liner. I mentioned that sometimes we do line these systems. So we're putting in a liner so that the water doesn't get away from us and keep it. We put in the under drainage to pick up the water from the bottom of the system and take it back out to the storage tanks. You can see there. And then we put in the drainage layer, the transition layer, and then the filter media. Then finally, last step is we plant out the filter media, put our plants in. So this is the biofilter when it's just been planted out with plants, so it's brand new. Looks nice and clean, but the plants are tiny. The little wooden box you see here, that's the pump shed and the equipment shed. So we've got the pump in there to pump the water from the biofilter back for the irrigation systems, and we've also got the UV to disinfect the water before we use it for spray irrigation on the park. So we put all the stuff together in one spot, design it all as one thing, and then we had to make it look nice as well because I didn't want an ugly shed in this park. So in summary, basically it cuts down on our stormwater volumes and pollutant loads, cuts down on potable, potentially gives us some dual function for flood mitigation, but it depends on the design of the system. This one we're pumping out of the stormwater drain, so it's not really doing that effectively. We get these greening and cooling benefits. If we get told to turn off the water during drought, we can keep using our stormwater. And we're also reducing our reliance on desal and the energy that we need for desal. So it's a bit of a circular thing. We have climate change makes things worse, makes worse flooding. We build more desal plants because we're in drought. We haven't got enough water. We put more carbon into the atmosphere. We get worse climate change. It becomes a circular problem. So if we can reduce that energy use, that's a win-win. So So that's it for stormwater harvesting. Any questions on that? Any thoughts on how you might do something like this in Thailand, or maybe apply it in a different kind of way?
The big remoter tank underground, the big remoter tank.
Yeah.
Do they do the maintenance of that?
Do they do maintenance? Good question.
Well, the sedimentation.
Yeah. So we really don't want to have to go back into that tank too often if we can avoid it, because it's not much fun doing confined space entry into an underground tank. Melbourne Water hate underground tanks because they don't want to have to do confined space entry. But if you think about it, it actually doesn't matter whether it's above or below the ground, because you've still got to climb into the tank and it's still confined space entry.
Yes.
To try and minimise the maintenance, we put the water through a gross pollutant trap, which takes out any litter. Then we pump the water and we put it through the biofilter. And so the only sediment that can get into it is any fine sediment from the biofilter itself that's actually leaching through that goes into the tank. So the volume of any sediment that can get through is very small, and it's not likely to cause a problem in the tank. So hopefully you never have to go in and remove the sediment from that tank. But this is an ideal design setup where we have the treatment and then the storage. The problem with that is you've got to pump the water really fast to catch it, treat it, and then get it into the storage. If you can have storage before the treatment, then you can catch water, hold it, slowly pump it out into your treatment, and then store it. So that's the ideal way to do it. But the problem with that is that storage gets filled up with muck, and you have to maintain it. So this one, we've set up the other way. So we've done all the treatment up front, and then we have the storage, and that means we should hopefully never have to go into that tank to actually maintain it. Except for maybe once in 20 years we go and inspect it, make sure it's not structurally falling apart or something. So,
do you want to measure the quality of the water in the tank or not? Because it in the underground, and how you measure, observe that the quality is still good or not, something.
So quality is a consideration. In terms of nutrients, it's been pretty well treated. In terms of heavy metals and all that, it's pretty well treated. But the one issue we do have with this site is salinity. So the underground storages are connected to a pump sump, which is used to pump water for irrigation.
Okay.
So we can take the sampling from the pump sump, and it's the same water as in the storage. So that's how we test the water quality. In this particular case, what happens is that people pump their basement car parks, and they pump the groundwater that's coming into their car parks out into the stormwater drainage system, flows down the stormwater drainage system, and then it gets into our system here. So we actually had a problem in the early days that the salinity of the water was too high. We couldn't use it for irrigation. So we had to get rid of the water and get fresh water in to be able to use it for irrigation. So we have to monitor the system for salinity. And we've had to go back and retrofit the system now. So if we get water that's too saline, we can pump it back to the drainage system rather than having to use it for irrigation. So usually that's not a problem, but sometimes you need to.
What is the storage capacity of the tank?
The storage capacity for this system is 1 megalitre or 1,000 kilolitres. So
1,000 meter.
1,000
kilolitres.
So 1,000 cubic meter.
1,000 cubic.
cubic meter.
1,000 cubic metres.
1,000
if that
tons.
helps.
Is that a lot?
No.
In an urban setting, yes. In a rural setting, it's nothing. It's probably 50 or 200 would be a normal for a farm. And you guys, what is it, 200 cubic metres per second, so yeah, we'd fill it in no time. 5 seconds of water for your bypass. So the cost of that system is about $2 million Australian, because underground storage is very expensive. It's much better to do above ground storage if you can, or in rural areas it's much cheaper.
Thinking about underground and
Yeah.
if this idea can be used. But what is the capacity of underground dam?
It depends on. I mean that in that time at Phuket, the capacity of the underground dam it depends on the hole under, because we just only contact the layer wall. This is like a อะไรนะชั้นน้ำบาดาล aquifer
and the
aquifer
Yeah.
and the water at the aquifer will go to the sea
Ocean, yeah.
and we stop it with like a certain wall and the capacity depend on the whole of the aquifer.
Yeah.
So,
อร่อยบิ๊กเลย
when you design, did you consider the risk of an earthquake?
Risk of earthquake. We probably should. That said, we don't tend to do too much thinking about earthquakes for stormwater in Melbourne, and that's because we don't get too many earthquakes here. That said, we have had two, if I can remember, but they're usually off the coast and fairly minor. But yeah, certainly in Thailand that might be a factor you need to take into account more seriously
Just
than we
happened
do.
last 1 year.
It happened last year, yeah. Yeah. Any structure you need to think about earthquake, wind, all of those sorts of things. In this case, we're using a what we call a proprietary product. So it's a product being supplied by a manufacturer. So they have to do all the testing and assess all of those kind of risks and make sure that it's suitable, basically.
What a tank.
So
The tank.
for the tank to make sure it can withstand whatever it needs to meet the relevant standards. But yeah, definitely you have to think about earthquake, flood, all those things that can go wrong. So yeah. Yeah. And if you're building underground storages in Bangkok, then maybe you can think about maybe it's flood mitigation, but maybe you can hold some of the water in it and use it for reuse. But then if you know that a flood's coming, then you drain the system, just open the gates or you pump it out. We're looking seriously at doing that at a development called Arden in Melbourne at the moment. So they want a flood storage of 12.5 megalitres underground storage, and we're saying give us 5. Just give us 5 megalitres of that for reuse, and that will give us a huge amount of reuse storage that we can use to reuse stormwater. But then you'll still have most of your flood storage, and if a flood's coming, you can still empty that storage. That's okay.
Yeah.
And then we have a hybrid system, and then we get the best of both worlds. But we still haven't got people across the line who've been comfortable with that yet, because they're very protective of their flood storage, of course.
Yeah. I think the one thing we encourage you to think about is, because RD is building these so many deep tunnels. So think about deep tunnel is not only a conveyor system, but it's also storage, because you need pump both ways.
Yeah.
Right?
Yeah.
So that deep tunnel, particularly on the western part of Chopia, can also function as a flood storage.
Yeah.
When it's not used as a flood conveyance during the dry period, it is storage.
that if we store water inside and if it leaks, is that a possibility that it would wash away the soil in Bangkok is soft soil and it can be washed away and create this
The big
empty
no.
It's a tunnel, right? You build a tunnel. You already built it,
right.
right? You're using the internal space
Yeah.
for the storage,
And
right?
if
You're
it
not
leaks,
creating any.
if it leaks, it goes down,
Yeah.
right? Create an empty hole.
I mean, it leaks. I mean, you're building like a multi-billion-dollar infrastructure. if it can't be waterproof,
It still have now.
Right, yeah.
It's the tunnel under the road near our office,
Yeah.
MRT.
and it cracked,
Yeah.
and the soil outside it come to the tunnel.
Was that outside your office? The sinkhole?
No, I mean the this
because
tunnel is
Yeah.
under the street,
Yeah.
and the tunnel it have some crack,
Oh, yeah.
and the soil it comes in the tunnel,
Yeah.
and the street it sink have a big hole.
Water pipeline wash.
I think what happens is because you have that's a shallow layer, right? You basically when the water comes, it filtrates, it goes down, right? That is causing the instability.
Yeah.
When you have a deep tunnel, you're underlying because how the tunnel sits, right? The depth of tunnel is
Yeah.
determined by the consolidated layer,
Yeah.
right? You're basically saying if that layer can hold the tunnel, that's strong enough to be a waterproof.
It
The
has
water won't infiltrate because it's already compacted. Otherwise, your tunnel will sink.
yeah.
Right? You think about it, right? Your tunnel will sink.
Because
In case of Thailand, the failure of channel is the channel is okay.
Yeah.
It failed because the channel will connect by the underground station
Yeah. Yeah.
and try to use TMB method, try to connect with the station underground and collapse leak. So fail. Not by channel themselves itself. No.
It was the connection that failed.
When connection about failure, about method failure.
Yeah.
So you do need to consider, if you're using it for flood conveyance, then the tunnel is full of water during a flood, maybe a few days, and then it drains. If you're deliberately using the system for storage, it's holding water all the time, then the risk of leakage will be greater. So you probably have to pay more attention to making sure the tunnel is sealed, monitoring the levels so that if the water level's dropping and you're not using water, that you know that there's a problem. But yes, you will have additional considerations. I mean, if you've got it sitting on bedrock, it'll be okay, but you probably have quite deep clays in some areas. So I wouldn't say that the risks are insurmountable, but the risks probably are greater, so you probably do need to consider them and consider that geotech. Yeah. Any underground structure, you've got to
Yeah.
Yeah.
Shallow. Yeah.
This
bedrock.
the tunnel and the soil come to the tunnel and the sink.
That was close to your office.
เป็นเดลต้า
Yeah.
Oh, okay.
เข็มฝังไปลึกสุด30 เมตรเราคุณ
Not general, but it can happen.
Yeah, absolutely.
แสงพุ่งแข็งมันลึก
Have
สุ
you
ดประ
been
มาณ
under the Burnley Tunnel? You probably haven't because you're in the city. We have the Burnley Tunnel runs under the Yarra River. It was built in the late 90s, early 2000s. To this day, that tunnel leaks. And they take the water that leaks into that tunnel and they pump it and they put it through a recycling facility because there was such an outcry that they were wasting so much water. They take that water, put it through a recycling facility, and then they re-inject the water into the ground or they reuse that water. But every day that tunnel is leaking water because it's very difficult to perfectly seal an underground tunnel.
And she's talking about reverse leaking, right?
Yeah.
Because
Leaking
every
out of the
basement
tunnel.
leaks.
Yeah.
Because every basement you have to put a pump up.
Yeah.
That's the groundwater leaking into the basement.
Yeah.
That's okay. That's what happened to this tunnel. But no one is talking about reverse. Right? What if the tunnel is half full of water? What is right? Is that?
Yeah.
But if you're holding water permanently in the tunnel, as opposed to just temporarily, then there will be more risk of that. But it will depend on if you've got a leak, but also the soil underneath it and whether there's somewhere for the water to go. Because where you have a problem is when that water is able to move that soil and take it somewhere through an outlet and then it can erode a hole. If there's nowhere for the water to go, then the water can pull up there, but it can't take that soil away. But your risk is that if you've got underground cavities or you've got something going on, then it might move the soil and then you can get a problem. So I think you do need to consider the geotechnical
Think
issues.
about the weight of the tunnel and the water itself.
Is heavier.
Too.
Yeah.
Because Joe said we don't know how deep is the bedrock, but it's very deep.
Very deep.
You know,
I think it's. I mean, this is worth to understand. We all need to understand the in situ soil in Bangkok, right?
Yes.
In the whole Bangkok Delta. I think a couple of years ago, my understanding is that you are on alluvial layer, and you basically similar to Netherlands, right? Rather than piling all the way to the bedrock, you actually build many piles that is actually floating on the clay. I mean, we have architects here, right? You build many piles, right? Not all the way down to the bed layer, but almost like you're building a boat. That's how you stable this, right? So when they design the tunnel, did you design a tunnel? They should be able to make the tunnel, it actually float on the
I see.
the weight and
When we did the tunnel already, the tunnel and the the soil is
ไปด้วยกัน
homogeneous.
Homogeneous.
Yes.
Yes, homogeneous.
If some earthquake
เควส
is
แล้วก็เขย่า
Yeah, it's just shaking.
the same,
Yeah, shaking.
the same way.
As long as the soil is consistent, yeah.
Yeah.
But yeah, in Bangkok, the pile of the high building
Yeah.
is stay on the steep soil, steep clay,
Okay.
not the bedrock.
No bedrock, right? Yeah.
Bedrock.
Okay. Yeah. Okay.
Maybe around 30 meters.
30 meters. Yeah.
The deepest. Normally 18.
Okay, good discussion. I'm conscious Catherine's got
Yeah.
one more question. And Catherine's got a few words she wants to
She would
say.
like to ask about the about the NBS can count or claim the carbon credit for your country.
Carbon.
Can you use
Carbon
it as,
credit.
Can you use it as
carbon
carbon credit?
credits.
Yeah. For
The benefit of the
Yeah.
carbon credit
Carbon
for the
credits.
NBS, it can.
It's complicated. You can and you can't. We tried to get a carbon tax in Australia many years ago, and it got shot down politically. So we don't have such a good mechanism. We do have carbon credits that you can do, but they don't have the value that they should have. You can do it, but it works best for large systems. So the ones that they're actively pursuing are things like mangrove wetlands. As probably the ones to look at, because the larger scale systems like that, they can have quite significant carbon capture. So it's worth looking at for that. And there are people that are actually actively doing mangrove wetlands and restoring them to claim the carbon credits and then get funding for the projects as the way to get happening. And then they get all the other benefits along with it.
So I can say two things because I analyzed the NAP, the National Adaptation Program for Thailand, and also looked at the NDCs. And I know, like in the NAP, it's very clear that they recognize urban nature-based solutions as an adaptation measure, especially in terms of like water management and urban cooling. So any actions taken will help achieve, like in terms of integrating nature or nature-based solutions into urban areas or into rural areas where it makes sense, does help fulfill the targets for Thailand. The mitigation I don't know as well, but I know that, for example, when we were working with Department of Climate Change and Environment and PTTGC, so the reason why they have rehabilitated some old like waste transfer sites or industrial sites is to claim carbon credits. Now, it's questionable, like the sites are not very big, so I question how much carbon credit you actually are getting, but I think, well, Hima can even talk more about it, because when you do a benefit cost analysis, that's something that can be taken into consideration, depending on what schemes are in place in the country. I don't know, Hima, do you want to add anything? No? Okay.
Sorry. No, I don't really have anything to add.
Okay, all right.
Thanks.
Yeah, but I can also share with you that, like the case studies that we did look at that element, but it was for a small park in Bangkok. But yeah, it's complicated. The reason why it's complicated is because also wetlands emit methane, so that also is a kind of gas. So you have to sometimes look at the trade-off there as well. Yeah. So it depends on what the scheme is in Thailand.
Example ซีกาค่ะมันเหมือน absorb carbon in soil
Mm-hmm.
claim carbon credit
They claim, so in Thailand, they count the carbon contained in soil as carbon credit?
ไหนเรียนต่อมันเคยเห็นนะ
I think in academic we kind of in landscape design we kind of talking about the carbon sequestration quite a lot recently, and in a very general way they're trying to make an assumption that wherever they have a vegetation area you can say that, but in the measuring, like exactly the number. We not develop into that yet. But answering your question, I think you can do it. But maybe it's not like supposed to be a very proof way in the number kind of thing. But we are recently developing, trying to engage to make it more area of the green area vegetation with a very simple understanding, like you mentioned, the vegetation and carbon. That's it. But when going to the deep down, we don't have that yet.
So there will be some numbers on mangrove wetlands, and the other one is we didn't talk about it today, but the passively irrigated street trees. If you look into the iTree calculator, which is a US tool, you'll find that there's values for how much carbon different types of trees in an urban setting can capture. So that's probably two avenues. One is your bigger mangrove wetlands and that sort of thing, and the other one is the urban trees. There's potential for estimating the amount of carbon that they can sequester as well.
Yeah, and they are actually like the species of tree. If we can work with the horticulturists, so they have the list of the tree and which tree that can things like that. So you can
58.
Connect the dots.
Yeah.
Possible.
If you plant this type of tree in NBS zone, you can get the carbon
But you
negative.
just have to make sure it's a native plant, not like a plant that grows somewhere else.
So just before we wrap up for today, again, the presentation materials, we're uploading information. There's one folder called resources. So I've been adding some of the documents that Dale has mentioned or Helen has mentioned. So some of them are in that. So we'll keep adding material in there. And I think I shared the QR code with Naraman and Jok, so they can share it around. So just really quickly, I have to do this. Yesterday, Helen, this will take 5 minutes. So yesterday, Helen was talking about thinking about how to be inclusive when we're developing nature-based solutions. And so I just wanted, in that resources folder, we have a guide that we developed last year on inclusive and equitable urban nature-based solutions. And, I mean, it doesn't have to just be applied in urban areas. All the examples are from urban areas, but the principles and concepts. So we are in the process of developing a summary that's easier to read and understand. And we plan to translate the summary into Thai. And just in discussion with Department of Climate Change and Environment, look at linking to the Thai context. So for example, TCC have some gender guidelines on adaptation. So making sure that it's relevant to Thai context. And then we've been using the guidelines to develop and facilitate workshops, designs, and other guidelines. So who's the guide for? Well, lots of different people. Probably most relevant, infrastructure project designers and developers. So why do we have this? I think what Helen was mentioning yesterday, that and as we all know, the most poor and the most marginalized are often the most affected by flood, by rapid urbanization and climate impact. So they often live in marginalized, the worst land, the hottest area of the city. And then it's not just about social policy, it's thinking like if you design for the poorest or the most vulnerable group, it's going to work for everybody, it's not going to work just for them. So also when everyone is included, or different groups are included, then it helps the whole system become more adaptive and resilient. And as Dale was pointing out, safety is important, so it ensures that there is safety included, and also creates ownership of whatever you're developing. I've got like 4 slides, so because this is like a very long guideline. But just in short, the way that it's structured, it has like a lot of key concepts, and then there's 4 main parts: project planning, project development, project maintenance, and then a reflecting, monitoring, evaluation, and learning part. It's not prescriptive. It's not like you have to follow step by step. It's more like it offers suggestions and principles to help specifically projects that integrate nature-based solutions. So, for example, in the planning step, the idea is to plan inclusion from the beginning, consider who should be involved, different groups, different perspectives, going to have more success, understanding what the issues are, like as Janvin has said many times, like understand your problem, and but also understand how different people see that problem and how it affects them. And in order to do that, you need to talk to different people. And then often, like as you probably well know, often the most vulnerable groups are the ones that don't have much voice or much power. So just thinking of how to actively engage those groups. And then, as I said before, like looking at the problem from different perspectives. So for example, when addressing challenges such as flooding, integrate perspectives from street vendors, low-income renters, people with disabilities to understand how floods affect them and how you could reduce risks for them, but then for everybody else as well. In terms of development, I think that's what we're going to try to think about more in the next training, is how to design solutions together with different groups, different perspectives, so stakeholders can understand and influence decisions. We heard there's a lot of pushback on projects, but obviously when people have a greater ownership and understanding, maybe they're more likely to come on board, not always. And then Dale has mentioned about accessibility elements in design, so that people can move safely, that they're usable for children, people with disabilities, there's lighting, and that there can be relatively easy maintenance. And then other aspects in the guide that are mentioned are think about who benefits, who might be harmed, and how can you affect any harm, or how can you mitigate any harm, or reduce harm, sorry. And then agree on who is doing what in terms of development and implementation, and then making sure that there's fair budget and procurement processes that supports inclusion in practice. So for example, if we want to hear people's voices, we need to have resources or space to hear like women who might, not be available at 10 o'clock in the morning, or farmers that might not be available to the evening, if you want to hear from them. Okay, maintenance. This is quite straightforward. Assigning ownership of upkeep. That's to do with local ownership, local knowledge, and then ensure that there's budget for maintenance, so the asset doesn't degrade. Access and safety are very important. Dale has mentioned that many times. And then supporting inclusive use. So if there's maintenance, making sure that people can still access a park or access the path. So for example, for like a park, agree a practical operation and maintenance plan with the municipality, and then there could be, getting feedback from women and people with disabilities to flag access and safety issues early on. Okay, and then finally, monitoring, evaluation, and learning. So thinking about what to monitor, like what do you want to know in terms of inclusion, so who uses it, whether it's addressing safety and comfort, or benefits are being shared, how to monitor, what process are you going to use, how to evaluate, so what are you evaluating? So what is the project intent? Ideally, the project intent should have a vision that is inclusive, so that, for example, if you want to do flood mitigation, it's flood mitigation for everyone. So is there anyone that is impacted or harmed due to the implementation? And then how are you going to use that information? Can it be used to adjust the design, change how you do future projects, on how you do maintenance? Okay, so that's all. I told you it'd be quick. So I'm not going to go through this, but so Helen put this together. So the thing is, tomorrow, like you're going to, and the next 3 days, you're going to go to different sites, and we'll give you a piece of paper. These are just things maybe to think about. So when you're looking at a park or a site or anything, think about like how different groups would view this, like what are pluses, what are minuses, you know, how would this be applicable in Thailand, for example? So I'm not going to go through this, you can read it. And then these are, we don't have the answers to these are the sites we're going to, but I guess these are things to think about, like around community consultation, like how would that work? Who would be involved? How are people targeted? Yeah, so just these are just some questions that she put forward to think about. So that is it. So again, we just have a, similar to yesterday, we have a short survey to understand what you understand. So if you can complete that, I'm probably not going to join you for the next 3 days, but we will have a survey at the end of each day. I hope it didn't take long. We tried to make the questions very short, but it's really helpful for us. So yeah, if you can do the one today, and then we'll send around the QR code at the end of each day for the other days as well. That's it.
Thank you. Thank you,
Thank you very
Catherine.
much.
Thank you, Dale.
Thank you, Dale.
Thank you, everyone.
Thank you.